Okay, what I plan to do here is just go over some of the basics of Laplace, of what the Laplace transform actually does, what it looks like, a little bit about what it is, and just try to go through some of the basic Laplace transforms. So first of all, what is Laplace? So if we say that Laplace looks like Laplace of f of t, the Laplace operator of f of t equals. So the definition of Laplace is the semi-infinite integral, so that's the integrand between infinity and 0, of f of t, e to the minus st dt. No, it's as simple as this. And that's all it is. That's all Laplace is for any function. So if we just think about that just for a second. So if we have, say, two axes, t, and here we're going to have the function f of t. And let's say we have, I don't know, let's say we have a sine function, something like this, okay, between 0 and 2 pi. If we multiply this by e to the minus 1t, so we know what e to the minus 1t is going to look like. E to the minus 1t is going to look something like this, okay, for t is greater than 0. So if we multiply this sine function by e to the minus 1t, we're going to end up with something that looks like this. Okay, and it's going to basically have an exponential decay to infinity. The frequency domain there isn't actually correct. The frequency relative to the original wave isn't correct, but that's not important. The important thing is that if we multiply something, any function, by a decaying exponential function, that function is going to just have an exponential decay as t tends to infinity, providing s is large enough. And that's really, really important. Whenever you do a Laplace operation, the assumption is that when we multiply the function by e to the minus s of t dt, that s, the magnitude of s, is going to be large enough such that when you multiply that function by this exponential decay, it will actually decay to 0. So that sounds a bit confusing. So what on earth does that mean? Well, let's say you have a function like this, say e to the t, something like that. Okay, and then remember what we said, e to the minus st is going to look something like this. Yeah, if s is small, what will happen is that this function over here will actually be increasing at a greater rate than the function, than the negative exponential function. And then this is actually, then the product of those two functions are actually going to increase as t tends to infinity. So that's just a point to bear in mind, which will be very important later on when we start to evaluate these integrals of slightly more complicated products. But for the time being, just bear in mind that s has to be large enough such that the product of these functions will result in this exponential decay. So let's try doing one. And again, this is a bit confusing for now until we see some other functions. But let's just have a look at, let's say, the Laplace function of a, where f of t equals a. So all we've got here for f of t equals a is something like this. Okay, straight line, like that. Yeah. This is t, this is f of t, and that's just a. So it's just going to be a horizontal straight line. So what is the Laplace operator going to look like? Well, let's have a look. So the Laplace function of a will be the semi-infinite integral between positive infinity and 0 of f of t. Well, that's going to be a e to the minus st dt. Yeah. Now, we know that a is a constant, so we can just take the a out, and we can say a of the integrand infinity and 0 e to the minus st dt. And now we can just simplify this, actually perform the integral, which will be minus 1 over s e to the minus st, evaluated at the limits between infinity and 0. Okay, and what we can do, we can take the negative 1 over s out as well. So we can say minus a on s e to the minus st evaluated between positive infinity and 0. Okay, so how do we actually evaluate this, e to the minus st, as t tends to infinity? Well, let's have a look and see what e to the minus st actually looks like. So we've got an exponential decay function, which is going to look something like this, yeah, as t gets larger and larger. Now, if s, remember what we said, that s has to be large enough such that when t tends to infinity, the product of this and the function is going to be 0. Well, that just means in this case that s is large enough. For instance, let's say s was less than 1. Sorry, less than 0. this is actually going to result in a positive exponential growth, like that. So providing that s is small enough, what's going to happen is that this is actually going to decay to 0 when t tends to infinity. So we can say that this is going to be minus a on s. I'm just copying that down. So as t tends to infinity, e to the minus st is going to be 0, minus e to the minus 0, which is 1. Yeah? So this is going to be minus a, sorry, that should be minus a on s times minus 1 equals a on s. And now we have our first result. So the Laplace transform of a for f of t equals a is simply going to be a on s.